Today we're going to talk about how to find the derivative of a product of two functions. And just to be clear what that means, if we take a look at the two examples down here, we would call these functions a product of two functions because each one of them is made up of one function of x times another function of x. It's a product of e to the x times 3x to the fifth. I can't simply use the power rule on that. I can't use the chain rule. None of those apply. It's a completely different set of rules. So first of all, I'll show you what the rule is, and then we'll talk about why. There are three ways to write the rule. The first one I'll show you is the one that I like. I like using function notation. So if some function is k of x is the product of two other functions, f of x times g of x, then k prime of x is equal to the derivative of the first function times the second function plus the first function times the derivative of the second function. I will point out that the order you put these in doesn't matter at all because both multiplication and addition are commutative, so you can switch the order of these two all you want. You can switch the order of the products all you want. Like, that doesn't really matter. As long as the derivative of f goes with g and f goes with the derivative of g, it doesn't matter which one comes first. The other way to say this is using the other notation for derivatives. You can just say the derivative in respect to x of the product of two functions, u times v, is equal to u prime times v plus u v prime. Two ways of saying the same thing, different notation. The third way, notice I gave a little bit more space there, the third way is to describe it verbally. So I do want you to be able to make this sentence in English. The derivative of a product of two functions so far all of those words is just describing k prime of x is the equal sign. The derivative of the first function, actually let me say it a little bit differently, sorry, is the sum of, so I'm describing that plus sign first. And that's important to remember that the product rule, when you're taking the derivative of a product, you end up with a sum. You end up with two things being added together. It's the sum of, now I've got to describe the two things that I'm adding together. The first is the product of the derivative of one function times the derivative of, times the other function. Derivative of one function times the other function. And that whole big thing, all of these words, the product of the derivative of one function times the other function, that is all f prime of g of x. Plus, so I already said sum, so you can say plus or you can say and, plus the product of the other function, the product of the derivative, the other function's derivative, times the first function. And that's the f of x, g prime of x. There's a lot to memorize in words. I think memorizing the function notation is your best bet. Let's see it in action. If y equals e to the x times 3x to the fifth, that means y prime, its derivative, would have to be the derivative of the first function times the second function. Hey, that looks familiar. Plus the first function by itself times the derivative of the second function. And you can leave it like this. It's a little bit weird to put the e to the x first. You can certainly leave it like that. You can also notice that there's a lot of factoring you can do. You can pull out 3x to the fourth e to the x, which would leave you with x plus 5. All of those are correct ways to write this. For the next one, we'll do the same thing. Y prime is equal to the derivative of the first function times the second function. Put those arguments in parentheses to make it easier to read. Plus the first function on its own times the derivative of the second function. And for this one, there really isn't anything you would do to simplify that. So that's it. That's the product rule. I do want to show you where it comes from, because again, as I've said, you shouldn't trust me. You should verify for yourself. So the only way we can really find the derivative of this product is by using the one method we had for finding derivatives, which is the definition of a derivative. According to the definition of derivatives, k prime of x, so the derivative of this product would be the limit of the difference quotient, which is k of x plus h. So we're going to plug the x plus h in to the f times g, minus k of x all over h, all over that horizontal distance, as h approaches 0. Well, there's nothing you can do to this the way it is. So what we do here is a very clever use of 0. So what we're going to do is, because we're allowed to, so hey, why not? And I'm going to add 0 to the numerator. The way I'm going to add 0 is by adding in f of x plus h times g of x, but also subtracting f of x plus h times g of x. Of course, I'm allowed to do that because if I add something and subtract its opposite, I'm really adding 0. And so according to the inverse and identity properties, I'm following all the rules. What I'm going to do now is reorder that because I want to use the first one. I want to actually leave that one where it is. I'm going to move this one. I want that minus f of x plus h times g of x. I actually want to stick that in here. Of course, because of the commutative property, I can move addition, subtraction around all I want. So I'm not breaking any rules if I do this. It'll just be easier to see what I'm doing if I rewrite it. So I'm going to rewrite this as the limit of f of x plus h times g of x plus h minus f of x plus h times g of x. And then I'll go back to having this term as next, minus f of x g of x plus f of x plus h times g of x. All of that over h as h approaches 0. And you might have an inkling of what's coming next. The way I grouped those expressions, I grouped it in a way that I can do some factoring. The first two terms have f of x plus h in it. The second two terms both have a g of x in it. So what I'm going to do is factor, it's almost like I'm factoring by grouping. I'm going to factor the f of x plus h out of the first two terms, which leaves me with g of x plus h minus g of x. And maybe you're seeing what's about to happen, that g of x plus h minus g of x is kind of a giveaway. And I'm going to factor a g of x out of the other two terms, which leaves me with negative f of x plus f of x plus h, which, by the way, it's a little bit helpful to see what I'm doing if I reorder those two. Notice how I kind of switch the order of those two terms. And again, this is all still over h, But one thing I can do, because it's going to help me in just a second, when something's all over h in a fraction, I can split it up into as many fractions as I want. So what I'm going to do is split that up into two separate fractions. So it's still the limit of all of this as h approaches 0. Of course, one of the things we learned about limits is if you have the limit of a sum of two things, you can chop it up into the limit of two separate things. So that's what I'm going to do. The limit of my first fraction as h approaches 0 plus the limit of the second fraction as h approaches 0. And perhaps you're spotting what's about to happen here. Notice this and this. Well, those are derivatives. One of them is the derivative of g, the other is the derivative of f. I'm almost ready to pull that out. The only thing I have to do first is separate each of these two limits. The first one here, the limit of a product. What I can do is write that as the product of two limits using our limit properties. So I'm going to call that the limit of f of x plus h as h approaches 0 times the limit of g of x plus h minus g of x over h as h approaches 0. Notice how when I chop up my multiplication, I only need to put that h factor, I only need to put it in one spot. I decided to put it in my seconds with the second factor of the limits. With the other one, it's a little bit easier. The g of x, as far as h is concerned, g of x is a constant, and we know the limit of a constant multiplier is equal to the constant times the limit. So because g of x has no h in it, I don't need to worry about the limit as h approaches 0, and I can just pull it out. And so now we have three limits left to do, and we can do all of them at the same time. The limit of f of x plus h as h approaches 0 is just f of x by direct substitution. The limit of this next one, g of x plus h minus g of x over h as h approaches 0, well, if I try to do direct substitution, I get 0 over 0, but I don't even need to do that because I recognize that that right here is the limit definition of the derivative of g of x. The g of x is still here, and this last piece, the limit of f of x plus h minus f of x over h as h approaches 0. I just realized that's a mistake I made there. That shouldn't be x, that should be h. That's also a limit definition of the derivative of f of x. And so there we have our product rule.